Right, here we go. Hello, everybody, and welcome to the Cosplay podcast. And I'm your host, Danny Huang, and with me today, we've got James Bruton of X Robot. And would you like to introduce yourself for those that do not know about you?
Okay, cool. My name's James Bruton, and my website's xrobots.co.uk, and I'm a YouTuber. So I've been doing YouTube, I guess, for about 3 or 4 years. And the plan is to try and do that full time one day. I'm about 50% of the way there, I think. So I do weekly build videos, doing sci-fi props and costumes and various other things about 3D printing. I use a lot of 3D printing basically to get that content out. So I do a lot of mechanical design as well as electronics and other things. And I do use other traditional methods like vacuum forming, hand building stuff. But 3D printing is really useful to get the mechanical parts made each week, and I have done 2 videos a week at some points. I currently have 4 3D printers, which run. You say? Oh wow! Yeah, 4, and they pretty much have in the past run 24/7 through the night and everything, just to get those parts made to get the content out on time. Oh, I see. So yeah, I'm doing about roughly 1 million views a week at the moment. So wow. It's a fairly big audience. And people complain if there's not enough quality content in each video. So, you say you're a YouTuber. Are you sort of completely independent? Because I'm aware that most YouTubers, they're part of multi-channel networks or something like that. Yeah, I'm in a multi-channel network, CDS in Beverly Hills.
Oh.
I'm not sure if I'm going to stay in at the moment, but not too much on that. Okay. So, yeah, there are collaborations with other channels, but I've done a few things where I've 3D printed something and sent it to another channel. So you get a video where I make a mystery object and put it in an envelope and send it off, and then they've got the video of opening it and using it for their project. So yeah, there are some collaborations and some more stuff like that coming up.
Okay, I picked the right guest, and I believe recently you got a new day job. You make toys, isn't it?
Yes, I am a toy designer for an international toy company. They're not keen on me shouting about it.
Oh, okay,
for reasons I can't tell you. But yeah, so basically they have a Lucasfilm license, so doing Star Wars tech toys, that sort of thing.
Oh, I see.
It's very exciting.
Yes.
Lots of stuff coming up. I can't tell you anything about, I'm afraid. But essentially, yeah, it's using 3D printing electronics, doing that design for tech toys, some flying toys, some stuff. Other stuff I just can't tell you about, unfortunately. But yeah, it's very exciting. My previous day job was working for an insurance company for 10 years in IT, so big change. Really happy.
I see. Again, that's you're very blessed, sir, because not many people get to do what they want. Most people, they do a job like myself, which just pays the bills, and you go home, and that's why in that case, that's why we do cosplay, to sort of escape that. But in the case of, I guess you must actually look forward to your work now.
Yeah, it's not bad. I've got about a 40-minute commute, and I have to leave really early to miss the traffic. So yeah, it's not bad at all, because you're going in to just do what I enjoy doing. And they actually approached me and found me through my YouTube channel, offered me the job. So it's not often that sort of thing happens. It's really, really good.
Oh my, you were headhunted. I mean, I guess you must have been honoured, because again, we have to apply for work, but it's a case of here's a job.
Yeah, pretty much.
Right now, Paul. Now introducing you, this is kind of interesting. I think you technically technically have the term, you wear many hats. I mean, you got a day job, you do prop stuff, and do YouTube comment as well. You do the same profession as me. So why don't you introduce yourself? That might be easier.
So hi, I'm Paul. Thank you for that introduction. And so I founded 2052 about a year and a half ago now, and that actually started off as a company that sort of exclusively did props for 3D print, like 3D printed props for the cosplay community, and that really evolved over time thanks to the space I was in, and also the positive feedback from all the cosplayers. And now, really, we kind of do the cosplay stuff more for fun than we do as our kind of bread and butter, because it's where we started and we really enjoy it. So that's hat number one, I guess. Hat number two, I'm actually doing a PhD around 3D printing and the kind of validity of it as a manufacturing process. And then my third hat, which is kind of my current main job, is that I work for Autodesk as a product design expert. So Autodesk are a company that make computer-aided software, for anyone who doesn't know. So that's me, really. That's what I do.
Oh, okay. And I guess we should actually talk about our subject, which is 3D, which is actually 3D printing. Now, is 3D printing the future of prop making? Do you think this will like take over traditional analog crafting, especially as the technology becomes cheaper? Because yeah, these 3D printers, they're getting cheaper and cheaper. Because before, oh goodness knows how much they cost, but now they're actually getting to the cost of, let's say, a gaming laptop, like 1,000
Yep.
quid. I think there was an
Less than that.
Less than that. Oh, okay.
Yeah,
please.
you can get a kit now for maybe a Prusa i3, which is an open source printer, about £450. Some of it's made of wood, but you can pick those up on eBay.
£100.
And from the fairly reputable sellers. So I'm a trustee of my local makerspace, Southampton Makerspace, where we have 3D printers and people come and use tools, but people also come to get help building their 3D printer kits. So there's at least one seller on eBay who we practically endorse and say, buy that kit and we'll help you build it. So depends if you're more interested in making stuff with the printer or building the printer. Personally, all my printers are Lolsbots, which come ready assembled, but the cheapest one's about £1,000. So with a warranty, comes and works out of the box within 20-30 minutes. So yeah, prices are coming down a lot.
Okay. Do you know if that so-called £400 one is any good? Because I remember distinctly. Was it Paul Sohi, who hopefully will be edited in, much editing later, and described that the current printer he had at the moment was the equivalent of a pocket camera. Is it? Because I understand just like printing, you got different resolutions and precisions of printing. So would you know if it was any good? I mean, obviously compared to the hardware you have.
Yeah, sure. I mean, you could get the similar print quality out of it if you're prepared to sit there and tune it and adjust it a lot. Obviously, you have to build the thing from a box of parts, and you get wooden cutout parts, but you have to drill the holes and so on. So yeah, it is a challenge. But yeah, you can get reasonable print quality out of it if you're prepared to spend the time. If you're not, from a mechanical background, you are probably better off buying one that's ready assembled. So yeah, the Lolsbot Mini's pretty good for £1,000, and that's basically the same quality that I use for all my parts. So in fact, I've got Mr. Fusion right here.
Mr. Fusion.
From Back to the Future. So the base of this was printed on actually the older Lolsbot, which is basically the base in the movie was made from a Singer Librascape, which is a piece of 60s computer gear you can't buy anymore. So someone did track one down. They paid $700 in the US. But I made this for about £30 worth of plastic, and the top is the coffee grinder. So if this is a sort of quality prop you can get out of one of those printers, if you're prepared to spend the time. So yeah, it's useful for those sorts of parts you can't buy anymore that look mechanical, because making that by hand is a significant amount of effort.
Yeah, because let's face it. Going back to the topic of is this the future of prop making? Because for people such as myself, and I probably should have gotten out my hidden blade. Again, much editing later, hopefully when Paul joins us. Because these 3D printing is accurate to, I believe, within micrometers, so you could you could obviously make ammunition if theoretically you would want to go to that trouble to actually go into chambers and stuff, because that's how accurate it is.
Yeah, sure. So here's a lightsaber that's 3D printed in lots of parts. That's only using a 0.3mm layer height, or 0.25 for some of it. But you can make some quite precise mechanical parts. So there you go.
Okay.
Comes to pieces as well. So that's a download, 14 pieces you print and then stick it together. But you don't have to do everything with 3D printing. So you could make the blade, for instance, out of an acrylic tube or some other material. Trying to print a very long, thin blade is probably going to be challenging. There's other techniques I use. So in some of my big projects, let's just turn the camera around. So there's Hulkbuster, which is my 7-foot tall Iron Man suit. The frame that's coming on nicely. Yeah, the frame is made of wood, so the silver parts that you can just about see, something poking out by the feet, that's wood. And then the next level was the black frame parts, which are actually 3D printed. So you can see some more sticking out the top. And then on top of that, I've used foam floor mats and foam boards to put the skins on. So, you don't have to do everything with 3D printing. It's much quicker to use sheet material for big flat sections, basically. It probably always will be. And cheaper.
Okay. But again,
so there you go.
Yeah, but again, getting back to the actual question, do you think this will become pretty ubiquitous? Because, it's a case of, as you say, if printers are now like £400, that's cheaper than most laptops.
Yeah.
So, will this definitely take off, do you believe?
I think it has taken off. I don't think there's any going back. Whether people will use it, I mean, it depends really, how much you've got to make. So whether you invest in a 3D printer, there are other 3D printing services where you can send off and have parts made.
Yes.
So there's 3D hubs where people register their own 3D printers. It's like a network. Then there's other things like Shapeways and so on where they're commercial services.
Yes.
So, for the odd thing, it's worth considering. If you can either get the CAD or design it, that you only want like one tiny buckle for a costume, then that's a really good way to get it made accurately. Shapeways can print in metal as well. But it depends really. You can still, make that part by hand if you're prepared to whittle away at a piece of wood and do some moulding and casting. So it really depends how much time you've got and what you want out of it. If you need to make 100 buckles, then probably 3D printing them is easier than... You could mould and cast 100, but it's going to make them all consistent and accurate and clean.
Okay,
so it probably is the future, depending on what people want out of it. If we're talking about cosplay, it depends how much money people have got to invest in it. And obviously things like fabric and other parts, they're still going to be made traditionally. But certainly the way the movie studios are going to make practical effects. So if you imagine something like BB-8 from Star Wars and those things, there's probably a lot of 3D printing in that. Some of the weapons, probably lightsabers, Dalek, eye stalks, all those things are, they're going to become 3D printed. So, because it's just the easiest way to make that custom shape. So if you want something that's movie accurate, then, and you want to make it in the same way, then maybe that's the way it will go.
Okay, then. Yeah, excuse the janky editing, but it should work. Trust me. Now, is 3D printing the future of prop making? Because I believe you are literally paid to advocate this technology. So I believe you've got quite a lot to say on the subject. So do you think this will take over traditional analog crafting, especially as the technologies become cheaper? I mean, just recently I've heard that I thought £1,000 was the cheapest to get, but no, recently you've got kits now that can give you access to 3D printing for just £450. That's like cheaper than a decent laptop. You can't even get a decent laptop for that kind of money.
Yeah, for sure. Just to address the first question, if 3D printing is the future of prop making, it really depends. I mean, the benefit of 3D printing versus analog is that you can make something tailor-made every single time. The machine you can produce it and you can scale it, and you can really bring that kind of... The idea is mass customization. The offside, of course, is that once an analog... so if you're doing casting, for example,
yes.
Once you have an analog, you have your casts ready to go. That's it. You can start producing them very, very quickly. Whereas, anyone who's worked with me in the past has seen that it can take quite a while because you've got to model the thing, which is a skill set in its own right, and then 3D printing it, which can take days at a time. And once it's 3D printed, that's not the end of it. You've got to sand it down and prep it and then give it a paint job. And there are some people out there who will 3D print and finish the process there, and that's kind of fine. But when you were talking about the specific context of props, you really want that prop to look like the real deal, right?
Yes.
And that's not going to happen straight out of the machine. And then in terms of it becoming cheaper, it's... I tend to compare it to photography. Like, by all means, you can buy a cheap 3D printer the same way that you can buy a basic cheap point and shoot, but you definitely get what you pay for. And 3D printing is right now, in terms of devices, is a real minefield because it's so popular. You've got companies popping up all the time saying that they're like the best or that they're the cheapest or whatever, but they haven't. You're buying into something that is entirely claims. There's nothing to back it up. And I always say, like, if you want to get into 3D printing, then buy a kit, but buy a kit with a really big community behind it, because then if something goes wrong, you know that there's someone out there who can help you fix it, and you can also see what the kind of quality of stuff people are producing. Whereas if you buy something that's £450, like when you look at the scale of 3D printing, some of them are as cheap as £450, and some of them, even at the desktop range, can hit about £10,000-11,000. You've got to factor in, like, why? Why is one of them so expensive and why is one of them so cheap? So it's very much a kind of like, be very careful. And then that kind of becomes exacerbated by the idea of, like, if you want to get into 3D printing, I mean, technically you could buy a 3D printer and just print stuff you find online, but you really need to have like the most successful 3D printing companies out there, or people producing the best stuff. Like, I love Crimson Coscraft, for example. That guy produces some absolutely incredible stuff. And the reason he's producing such incredible stuff is because he's an incredibly talented 3D modeler to begin with. And that's sort of your starting point. That's like what you really need to get into 3D printing.
Wow. Okay.
That's information overload there.
No. That's definitely. But like I said, so you've gone through quite a lot of machines, because I believe you said that to me at one point that the machine you had at one point was the equivalent of a pocket camera, whereas you were replacing it with something that was like an SLR.
Yeah. So when I started 2052, it was just myself at a desk in a studio called Makerversity, which is actually, I'm still based there in Sohi 2052. And over time, like, the space evolved, and so did we, and we ended up with these sponsorship deals from all these different companies, and now we have like a kind of a farm of 3D printers in that space. So that has been really beneficial for 2052 to grow, and also for us to learn about 3D printing. So we've had the benefit of playing with like the three major players in desktop printing, so MakerBot, Ultimakers, and the Up machines. And other machines along the way, like the Formlabs, which is a resin-based one, and then more recently, we're hoping to get into our space an Ember printer, and that's, again, it's like, that's at the very high end. That's sort of $6,000 for one of those. So yeah, they're a lot of money. So we've really had the benefit of being able to play with different machines and seeing what they're good at and what they're not good at. And it's just, again, the reason I use cameras is because one, I'm familiar with photography. I wouldn't say I'm a great photographer, but you have, like, people have those arguments all the time about Canon and Nikon, and
yes,
get the same thing with 3D printing. There's like the MakerBot camp, and then there's the Ultimaker camp, and there's no real way of saying that one is better than the other. They both have their place. So yeah, that's kind of like, that's sort of the state of 3D printers, really.
Okay, because I believe James mentioned that it is possible, even with a smaller, cheaper kit, that you could get a higher sort of it's hard to describe, but fidelity, I guess, if you fine-tune it. Is that possible?
Yeah, for sure. You definitely can do that, and it really depends, of course, on the kit that you're getting, and then whether that kit has it built into it to begin with, or it's something that you have to do aftermarket. But ultimately, like, all desktop machines are using what's called FDM, which is squeezing plastic out of a hot nozzle, and the technology is actually pretty basic. So with just a little bit of research and looking on the forums and talking to people who are more familiar with it, it is pretty easy to start to get better fidelity and better resolution, really. Like, we talk about the Z height. So the Z height is, every time the machine prints, it drops a layer of plastic, and then the bed drops down and it prints on top of it. And it's really to do with how much this Z plate moves. So that comes down to like the programming of the motherboard, and then the kind of the quality of the motors that you've installed in your machine. Which is why usually I say to people, like, buy the Ultimaker kit if you're starting out, because it is a kit. You build it, you learn how to use it, and you learn also what's going to go wrong because you're building the thing. And it's also something that you can grow with. Like, you can start with it and you can just use it as is for about sort of 6 to 9 months. And as you start to get more familiar with it, you can start to replace parts, which is exactly what I did. So, like, now I think three of our machines, they were completely custom. So we run like custom firmware on them. We've put custom nozzles. We've taken all the motors out and we've upgraded them so that we can get better quality out of our stuff. So yeah, it is certainly possible. Like, I wouldn't ever say to someone like, oh, unless you spend £1,000, you're not going to get anything that's worth using. So it is relatively accessible, but price point is always price point.
Okay, just to finish up this topic, because I think we've already automatically segued in how we're going to begin at this. But how soon are we before this technology becomes a little bit more ubiquitous? In the same way that DVD players once upon a time were like £1,000, but now you can pick them up cheaper than the DVDs that actually play them.
I think it's going to happen in two ways. One is that the market is going to grow to a saturation point, and then it will eventually collapse in on itself. But that's the same with every new technology. So we talk about like the hype as it builds up, and then you get to a point where people realize that this technology isn't what they were told it was, and you end up in this thing that's called the trough of disillusionment. And we're sort of teetering at that point now.
Ooh.
And when that happens, a lot of these kind of rubbish companies, for want of a better term, they're going to shut shop, and only the good guys are going to be left, and like the good companies. And when that happens, the prices are also going to drop with it to try and keep people going. But resin, not resin. Plastic cartridges are constantly getting cheaper, but FDM and desktop printing is only really going to get so fast because of the way that the technology is built. You're going to be limited by the motors. You're going to be limited by materiality as well. So I think that's where the most interesting stuff is happening, is when the chemical engineers are starting to play with the plastics and say like, oh well, if we change formulas this way up, or we change how we manufacture it, we can increase flow rates, and therefore we can get faster printing. But it's never really going to be super fast. It just isn't. It's, you know, but it also depends on how you define what fast is. So when we do non-cosplay or non-geek related work, and we're talking about custom products, sometimes people do say to us like, oh, that seems like slower than we expected. And the comparison is like, well, yeah, it's not happening overnight, but if you wanted to send that to a manufacturer in China or in Italy and have them tool up and prepare it and then ship it back to you, like, we absolutely are trouncing them, even with our post-production time. And that's really kind of how you have to scale, like what we talk about in terms of speed.
Okay, and on to the second point, the value. Yeah, was it the value? And changing it, and the value of 3D printing. Is it actually good value for money? Because again, I brought this rather exquisite 3D printed blade, one by a man called Amral, which was 120 quid. I remember having this conversation with you, and a lot of people say, yeah, that is incredibly expensive, but yeah, to the man's credit, it is a very, very reliable piece of equipment, and it's lasted me 2 years. And but again, 120 quid for pieces of 3D printed. Yeah, was it material?
Well, it depends whether you're paying him for the design or whether you're paying for the plastic, and it depends. Obviously, Shapeways isn't that cheap for printing; it wouldn't have been that expensive. But you know, he's still got to make his profit margin. Whereas if you designed it and made it yourself and had it printed at Shapeways, you'd only pay the cost price. So this lightsaber's probably about £2 worth of plastic.
Oh,
so if you own your own printer, I mean, we're talking about £16 a kilogram for plastic. And you don't have to make solid parts either, because you can put internal structures in, like honeycomb. So these parts are actually solid. But, you know, this is really lightweight. So, yeah, I'd estimate £2 of actual raw material. So if you've got your own 3D printer and you design your own parts, yeah, it's incredibly cheap. So as I said, Mr. Fusion's base was about £30 of plastic. It's about 1.5 kilograms. As opposed to $700 to buy the real item. And you probably spend more than £30 in moulding and casting materials, even if you could find someone who had one.
A fair point.
So yeah, in that case, it's much more economical and quicker and easier.
I see.
And you can custom everything yourself as well, of course. So, you know, if you've the original Singer Librascape, you'd have to have cut a hole in as well, and it was made of sort of cast aluminium or something. So you'd have to go to a machine shop to cut the hole in the top. Whereas with 3D printing, we can just have it made with the hole in, or any other custom features. So, yeah, I think it is good value, and I think as more people find it, they'll probably see that as a good method of doing things. But of course, people need to adopt the technology.
I see. Because I believe, because I was asking a person about why it would have been so expensive, and he explained that apparently Shapeways, which was where I got it printed, because of course that's how it works. You know, you can send the file and you basically buy a copy of it. They used was it some sort of a resin-based filament? Because there's all different kinds of filaments. Because I even believe there was ones that
Sorry, those the machines are a lot more expensive that they use. So they're talking about tens of thousands for a machine at Shapeways, and lots of those are selective laser sintering that fuse together powder with a laser. So you get much more accuracy with them and much more dimensional stability. So yeah, those machines do cost more anyway, but obviously they've got to employ their staff and have their premises and pay their overheads and make a profit. So yeah, I mean, it's going to be more than printing it yourself at home.
Because again, you could, rightly so. If you hire or commission a prop maker, you're paying for his time and obviously his tools and stuff, but it's essentially automated labor, and that's the thing that. But again, like, it does cost power, and essentially you are still charging for time because those machines could be making other stuff, I assume.
Yeah, if there's, I mean, I don't do printing for anyone else, but yeah, if that was your business, then obviously you'd have to make a profit. So, and it does take a long time. So Mr. Fusion was sort of a day and a half of printing. So, and then it was all made in small sections to fit on the printer. So every 2 hours, someone has to go and change the print over. Shapeways have some bigger scale machines, but yeah, it's still labour in checking the part can be printed, checking out that model is going to print okay, and obviously emptying all the spare powder out of the machine afterwards and setting it up again, and obviously packing it and sending it off to someone, all of the customer service stuff and everything else. So yeah, there's certainly people who sell on 3D hubs charge a lot more than the material cost, because it is actually quite a lot of hassle to print someone else's arbitrary model they send in that could be, impossible to print.
Okay, because again, you said it took a day for Mr. Fusion, which, well, that was quite a big diameter. But I guess for intricate stuff, especially with multiple parts. Okay, let's take for instance your lightsaber. I think you already said I should be paying more attention. But how long did that take?
So for instance, this piece, I think was probably something like an hour and a half.
Okay.
So yeah, it took several days, but that's because I didn't have all of the time free, so you have to go and sort of swap the print over. There's 14 parts in that, so I guess we're talking about, something like 14, 15 hours maybe, I guess, plus cooling up time, heating up time, swapping the parts over, and then obviously cleaning it up and sticking it together.
That's pretty amazing. That sort of, compared to, let's say, traditional prop making, where, again,
sure,
require intricate number of tools. I mean, of course, not also taking into account you still have to prime it. I mean, sand and prime it, I guess, and paint it.
Yeah, you can do. It's normal plastic, so anything you paint a plastic kit with, really. There are some build lines in there you probably can't see on the camera, but you can smooth those out through a variety of methods. But it's actually not too bad. I mean, it's got that kind of mechanical look to it. So, if you were to make that by hand, though, I mean, what are your choices? You'd have to really get a lathe, wouldn't you?
Oh, yes.
And look at that, so you could lathe round it, but then you'd have to somehow cut lengthways. So it's actually quite a challenging part to make by hand.
Yeah, I wouldn't have a clue. Again, that's definitely.
And to make that, consistent and accurate.
Again, down to the micrometer. And I guess, the value of 3D printing does 3D printing really represent a good value for money compared to, let's say, traditional casting, and do the prices. Are the prices like just made for automated? Now let's take for instance this fine specimen I got here, this Amra hidden blade, which this is I'm going to be honest, this is a fantastic piece of kit. I've had this for almost 2 years, easily by far superior than the horrid mass-produced rubbish by McFarlane Toys and NECA, which I buy them and then they break literally within the same, well, not before even the end of the day. They're hidden blades, but they turn into ballistic knives. But as you can see, it not only looks beautiful, it's actually functional. But yet, then people ask, where can I get this fabulous toy? I tell them it's £120.
Mm-hmm.
And do you think that's justified? Because fundamentally, it was a kit. It was all pieces of plastic.
I think really that comes down to. We're talking about skilled trade, so
yes.
The value and the cost that you're paying for is not the product, and it's the time that person took to make that thing. Now, this is where I would think that traditional methods are always going to kind of have the upper hand, because once you have your cast, you've just got to pour every single time, and of course there's post-production, etc., but it's going to be a lot less labor intensive than the guy with the 3D printer who's having to set his machine up every single time to print the thing out. And you're also paying for the modeling time, so the time it took for that person to sculpt that thing. Now, whether sorry, my phone seems to have picked up my speech. Silly phone. Now whether you're paying for someone to sculpt that thing as a caster, or you're paying for 3D modeler to to model that and then print it out. That's really where the price value comes in. So it's very easy for someone to say like, oh, well, you spent £120 on a custom one, but I could go and buy one from Game for like, I don't know, they're like 30 quid, right?
Cheaper than that, yeah. But they're horrid though. Yes.
Right. But then you've got like the easiest comparison point is, well, the point is like, one, yours is one of a kind or is one of a very small batch, and two, theirs is mass produced and it costs them pennies to produce. But you're kind of like I always find that comparison kind of frustrating, because it's like asking the boutique shop that's making one of a kind stuff to charge the same amount as the chain store that's mass producing everything and bringing it in. It's just never going to happen. And if you want it to be cheap, well, you know where the cheap stuff is. You can go and get that. Like, there's nothing wrong with it, but don't expect, like, I would say that you'd never expect a craftsman to be charging so little for his trade. You know, these people, they're making this stuff to live off of, and that's what you're paying them for, really, is that kind of craft skill.
Okay, because I heard there were like other factors, like when I was asking a friend why was it so expensive, he said that the actual filament or the plastic used is obviously a higher quality and something like that. So if I was to obviously do it myself and I had my own machines and that, I would no doubt it'd be considerably a lot cheaper then, wouldn't it?
Yeah, for sure, because you're not paying for your time, but also, and actually that's the point I didn't bring up, is the materials as well. So if you're using high-end plastics, they cost more, and you've got to take into labor time as well, and that definitely makes a difference. Of course, if you're making it yourself, the assumption is that if you're making it, you have the skills to make it in the first place, so you're not paying yourself for your time. But the guy who's made it for you has to have the skills to 3D model that thing and ensure that all the mechanics work, and that's also what you're paying for. Like in our studio, something that we've become has become quite popular with us is that there's a filament manufacturer who makes 3D print filament from recycled car parts. So they strip down the plastic interiors of cars and they turn that into filament. And we find that to be hugely popular because the grade of plastic they use in cars is much higher than the grade of plastic that they would use just to make 3D printed filament. And it's quite funny for us as well, because on the boxes it says, this filament used to be an old Mercedes-Benz. And we just find that really funny.
Wow.
So, yeah, I mean, grade of plastic also makes a huge difference in terms of print quality.
Wow. Okay, and I was looking at some of the prices that Shapeway charges, although you don't recommend them because there are cheaper alternatives. And I think it was 20 pence per cubic centimeter, which I can't even quantify. That's like smaller than a grain of a sugar cube or something like that.
Yeah, it's about the size of a sugar cube. The reason that I don't recommend Shapeways is not really to do with their print quality, but it's actually to do with the print process and the fact that they don't post-process. So when you get something from them, they use a process called SLS, which is selective laser sintering, and it's usually made from nylon.
Oh.
There's nothing wrong with nylon, but if you ever get a piece from them, you'll find that there's a fine coat of dust on it.
Yes.
And it hasn't been finished, and you have to finish it yourself. Whereas if you're using FDM, it may cost a little bit more, or it may cost around the same. It really depends on who you're getting it from. But you don't have that issue. Even if they don't post-process it, you're not going to get this kind of dustiness to it, and you won't have to essentially wash it. Because nylon printing is something that actually requires a fair amount of post-processing. Usually the way that I would do it is I put it in a tumbler with some abrasive balls and a slightly corrosive liquid, and that cleans everything up, and you get a kind of shiny, polished object.
Whoa, hold up. You put your 3D model part in a tumbler?
Yeah. Well, that's if you're using nylon.
Oh, okay.
That's if you're using nylon. But we're not talking about a tumbler like a washing machine.
Okay.
I mean, a thing that's sort of about this big.
Oh, all right.
No, not a dryer.
Okay, I was thinking to myself, wow, that sounds weird. Okay, thank God for that. I'd say that even though it is automated, although I think James did cover the point that you're printing it in parts, unless of course you have a Mahusive setup like Shapeways where you can do it all in one part, and it has you have to reload the cartridges, you have to throw off the dust and that. So there is still a little bit of labour involved, even though it is essentially automated. And if I remember correctly, when you were printing out a little miniature version of me as a chess piece, yeah, whatever happened to that? That was quite a cool idea.
Oh man, the chess. We'll talk about the chessboard later.
Yeah, yeah, sure.
So the me personally, and 2052 personally, when we 3D print parts, we 3D print in the parts the object would have been made of. So we recently finished up the bolt-up pistol, which
yes, I was going to
from
talk about
Gears of
that.
War,
Yes,
which that took quite a while. But when we 3D printed that, we 3D printed in its constituent parts, or within reason. We weren't going to print everything down to little bolts to assemble the whole thing. But the barrel and the chambers and the sights and then the assembly and the grip, they were all printed as their pieces, and then they were assembled afterwards. And part of the reason that we do that personally is because we find that once it's assembled and it's painted up, it actually starts to feel a bit more real, because those seam lines are in there and they're visible in the same way they would be in the real component as well. There is, of course, there's a very valid argument for printing the whole thing in one go as well if you wanted to, and that's really, you're time saving and you're ensuring a level of strength. So something that kind of came out of doing that for us, or that kind of insisting out of kind of design stubbornness, I guess, of saying that we're printing in the parts that makes sense for that object, was that so that we could say that it was more realistic. But then we also had to develop alongside that ways of ensuring strength. So we had to start developing our own excuse me, I've forgotten the word, adhesive. So we started playing around with dichloromethane, which is a
scary name, but yes,
it is a little scary name, but it's essentially a way of welding plastic parts together. So it melts the surfaces, and when you stick them, they bond together and they become sort of one piece. And we started playing around with that and adjusting kind of formulas and mixing in other things that we thought would work. And now we've developed a glue that we're really happy with, and so we use that to glue all our pieces together. But that's more time consuming. So that really is like a design decision. So whether you want to print it in one piece or you print it in multiple pieces really comes down to the person doing it. There is that third camp, which I find a little weird, which is that they're 3D printing in parts, but they just sort of slice in straight lines, like they've if it was made of a piece of cake and they've just chopped it. And again, if you're limited by your 3D printer, then fine, I guess you don't really have a choice. But it's something that you should be factoring in when you're modeling the thing.
Okay.
Yeah.
So, this is a question I asked James, and how long does it typically? I mean, of course, he has a different machine set up to you. I think he has 4 different machines. It's like I can't even afford one machine, but having 4 of them. Ugh. But and obviously, as he said, he's essentially but like as you said, you've got a farm now. So I guess it's kind of like a render farm where you're basically printing them out in separate bits. So, but let's say if you just had only the one machine, how long would it take to, let's say, theoretically print out that bolt-on pistol if had the modelling already been sorted out?
Oh gosh, let's see. There were about 9 different parts for that. No, 10 parts. There were 10 parts. We printed it at the highest quality we could. I'd say about a week. About a week of non-stop printing. So that's one set is finished, and then you put the next set on and you get it going. But bear in mind that the reason that's a week is because we were printing that at a resolution of 0.06 millimeters per layer.
Wow. Okay.
So that takes forever. If you were to print it at, going back and looking at it now, I probably would have done it at a tenth of a millimeter per layer, and then just spent a little bit more time sanding. But that's kind of how we did it at the time. Yeah, and it took about a week.
A week. That pretty much puts it on par with, I guess, a traditional analog prop. I guess. I mean, I'm not entirely sure because I've never made a revolver. But well, I guess it's going on to the next question. But we might as well mention it here. It is a proper revolver. So when you pull the trigger, the actual chamber spins around. Then.
Yeah, that's also part of the reason it took so long, is that assembly and ensuring that work. We had so many problems when we were building it and saying that the parts aren't strong enough. When you pull the trigger, like the mechanical wear, you'd only be able to use it sort of 10 or 20 times before the thing would break apart. So we had to spend like absolutely ages making sure that the thing worked. And we're working on a revision on it now so that it has the breakaway reload, which is something that we didn't include. So with the Boltok in the game, you'll see that it breaks like that,
Oh, it's
and
got
that's
break
how he gets
action.
the bullets in. But we didn't actually we didn't put that hinge in because we found that if we did that, then we couldn't get the spinning to work. So we're going back to it to look at that.
Well, it did take like almost 100 years to perfect the revolver, so I'm kind of guessing doing it in less than a week would be kind of, yeah, you'd be forgiven for trying to do that. Sweet. And this is a nice segue for the last point, which is, now how can people get into this 3D printing? What kind of software, and again, do you even need, I mean, as you already said, you don't necessarily need your own 3D printer. You can, again, send off the shapeways, and there's a number of, again, I've just noticed while doing some research, there's definitely more than one sources to actually just have your design printed off. So let's start with software and hardware. Do you need a particularly powerful laptop for 3D modeling? Because I remembered, I used to be an animator. We had 3D Max. So you needed a fairly decent PC, I believe.
Yeah, fairly decent. It depends what you use, really. So I use Autodesk 123D Design, which is free. It runs on. It's not particularly memory efficient, but my laptop's about 2 or 3 years old, and it runs fine on there. So you don't need anything particularly high power. It doesn't do anything like simulations or animation, so you're not rendering anything. So you're just doing solid modeling. So it works pretty well for basic parts. There are other bits of software that are free. There's FreeCAD, Blender, various others that you can use which are free, so you don't need to spend any money really. You can download these things and have a go, see if you can make some parts. You'll find probably people who are, if you see people who are good at sketching caricatures, for instance, they're quite good then at maybe sculpting naturally. So if you're good at those things, then you can probably do CAD quite easily. I'm not good at either of those things, but I can still draw mechanical parts and sort of measure them and make brackets and things, and that's fairly easy. Obviously, you can infinitely adjust something rather than having cut it out of a lump of clay and found it's wrong and spend ages making minute adjustments. So, yeah, it's possibly easier than some methods in a way to actually make that model.
Free Blender and FreeCAD. I'm assuming it is literally what it says on the tin. It is free.
Yeah, so I think FreeCAD is open source as well. It's totally free. Autodesk 123D Design is free. There's a whole suite of CAD stuff. It's not open source, but it is a free download. So, yeah.
Oh, that's okay. That's excellent then. So, I guess people can just download the program, and there's got to be a gazillion tutorials and stuff of how to use it.
Yeah, there's quite a few. Autodesk aren't particularly good at doing their own, but there's lots of them on YouTube, including my own. So, and some more coming, hopefully. So, yeah. But it's pretty easy. You can just drag down a primitive like a box or a cylinder and do a sketch on a face and extrude it through to make a hole, or click on a corner and chamfer it, and so on and so on. So you could probably get a fair way through doing this without too much trouble.
Okay, excellent. And was another like I said, another point. Do you have to be, again, we're getting, I guess, because this is more digital technology, and especially if you're making something like as intricate as my hidden blade, which I probably should have brought out, and you've got all your props ready, darn it. Would you definitely have to be more of an engineer than, well, would you say a typical, an artisan or a crafter?
Depends what you want to make, really, yeah. I mean, if you're making something that's more of an engineering piece that's got functionality in, then, yeah, it's good to have, that engineering aptitude or background or some knowledge of how you're going to make it work. But if you're just making something that's a buckle or a greebly for a spaceship, then it doesn't really matter, does it? As long as you know where the parts go, you can stick blocks and cylinders together to make it and cut bits out, then it doesn't really matter. Just because it's CAD doesn't necessarily mean it has to be engineering.
Because again, there's a massive misconception, especially with because again, I'm an animator. A lot of people assumed, it's 3D animation. You just go onto a computer, you press click, it does everything automatically. But I guess modeling something pretty intricate must take a while, doesn't it?
Yeah, I mean, I can CAD quicker than I can print, and I can CAD quicker than I can make it by hand. So from that point of view, it's more efficient. But depends what tools you use. There are, obviously there's downloads for things other people have modelled. You could just print. There's also other stuff in the Autodesk suite, like there's a monster making kit for kids where you just drag in arms and legs and you can put things together. And there's an iPad and Android app for sculpting a virtual lump of clay, which is a bit like ZBrush, where you can go and pinch the clay and make holes in it, and you can model it in in a computer like it's a lump of clay. So you don't have to be technical to do this. So, and 123D design I find is quite quick to make those simple things. So I've got a thing here that's a really simple flat bracket, and you can see some lumps on there, and those are to mount an Arduino on. So it's a little electronics mount for one of the projects. So that is probably literally 5 minutes of modelling, because it's just a square thing with some cylinders stuck on it. So yeah, it depends how far you want to go and what you want to model. And once you've learned the software and you know exactly how to do it, which tools to use, it's just a case of learning which bits to click on and what processes to apply. So you can do some stuff quite quickly.
Oh, okay, that's incredible. It sounds you make it sound too easy.
Well, it's certainly, as I said at the beginning, I find it quite easy, and I find that's the only way I can get the parts made in time to get my weekly video out. So yeah, ultimately a few minutes CADing, and then the machine makes the parts over several hours or overnight, and then I can do the talking on video for 10 minutes or whatever it takes. So yeah, I find it certainly easy. Without 3D printers, I just wouldn't be able to do it.
Interesting, because again, I remember watching a couple of videos where you printed out individual components for your Iron Man mask. Was it like what held the jaw plate, or the servers and all that? And wow. Yeah, with it. What I was meant to say is, going back to the engineering question. How would you even plan how to do a servo and all that? I mean, again, it's in one of your videos, but just for the benefit.
Yeah, so in terms of the angles, I think I used Lego to work it out, where exactly that the angle of the hinge and how it's going to move and everything like that. So most of that was by trial and error. You can get CAD software that will simulate, like Autodesk Inventor will simulate hinges, and you can actually move the hinge within the software to see how it works. I don't use any software that's capable of that, so I basically just do it by hand. So so the planning, it depends. If you're making something mechanical like that, then the planning can be tricky to imagine how that hinge moves. It can be simulated if you want to pay $4,000 for the software. Exactly.
Well, again, I shouldn't be too surprised, because once upon a time, in order to buy Photoshop, it was £1,000. But now you have that nice, lovely cloud service where you pay a monthly subscription. Yeah,
there is a piece of software called Onshape, which isn't a piece of software; it's a web service, which is a bit like SolidWorks, but it's free, or it's $100 a month for a commercial license. That actually does do simulations. So yeah, you can get a free version of that. All runs in a web browser, and you can make assemblies and make hinges and make gears that work and everything like that. So yeah, there's more stuff coming to challenge the high-ticket software.
Okay. Another point which I probably should add it on, and again, you can model software yourself, but I believe it's the custom within the 3D printing community to actually openly share files and stuff like that, because I believe, there was a guy I was asking, and he said, oh, look, there's a revolver, do you want that? I said, oh, yeah, sure, and he said, there, do you want it longer? And I thought, yeah, I would like a longer barrel, so could you actually do that? Could you actually find files and stuff like that? You could just modify them?
Yeah, there's a lot around. I mean, if you go on Thingiverse or Turbo Squid or GrabCAD, there's lots of stuff either for sale or for free. I actually give some of my stuff away for free. So my 3D printed R6 droid and my BB-8, all of that CAD is free. It's on GitHub, which is a free repository for code. So a couple of people are actually reprinting my droid. So you can do that. Some of my stuff I sell or I give away to patrons who fund my channel. Some of the smaller bits and pieces. But the R6 it's open mainly because it's part of the R2D2 Builders Club, and all of that stuff is shared. It's derived from those plans. But yeah, certainly there is a lot of free stuff out there to download. This lightsaber is a free download, and you could modify it if you wanted. So if you wanted to make it longer for some reason, no problem really. So absolutely.
The bolt-hock pistol. Now this is interesting because generally speaking, with cosplay, a lot of people, they're artisans, they craft, they make something that resembles something. But now when you talk about something like a pistol, that's engineering. Are you an engineer, Paul? Is that how you sort of was able to work out the revolver? But although, to be honest with you, there's plenty of diagrams of plans of how to make a revolver, because it's a very simple mechanism. As you say, there's only 9 or 10 parts.
Well, I studied architecture at school, so I know like this much about engineering, but I wouldn't say you need to be an engineer at all. It's really about problem solving and like figuring out. For us, it was like, okay, I want this motion to turn into this motion. and how do I do that? And that was really all we started with. So I drew it by hand, and I worked with my business partner, and we sort of figured out the best way to do that. But by all means, I'm not at all an engineer. And I think if you want to get into 3D printing and making your own props, you don't need to be an engineer. You just have to understand scale and measurement. And the way you do that is you buy a ruler.
Oh, wow.
You know, you don't need. I don't think you need much at all. Like, particularly with so if we're talking like specifically in the cosplay context, and you're, there's hundreds of reference images out there already because you're building something that someone else has already done, or they've created it. That content is there for you to then reproduce in one way or another, and whether you're adding your own spin on it or not, that kind of becomes your design drawing. So you don't really need to know a huge amount, other than be like, okay, this is how that works, or and you can figure that out from the images. Like E3 for me was a huge one of like, I've got 100 screenshots from the Phantom Pain trailer of going, I want to make that stuff. I want to 3D model that stuff out.
Yes.
And that's all I need. I just need those images. I don't think you need anything more.
Okay. My mind's kind of getting blown now, because again, I did a lot of asking around. There was a lot of people that were like saying, yeah, I really want to get into 3D printing, but they don't know where to begin. But of course, I guess they would just have to subscribe to your channel, and yeah, I've already done so, but I guess I should be paying more attention. And it's like, so I could, with, again, this is, correct me if I'm wrong, I could just go online right now, get some free software, find some of these files, and I could alter them with the free software. Or it doesn't quite work that way, kind of like certain files are only open with stuff or something like that.
Yeah, so a lot of the files that are distributed are STL files, which is stands for Standard Tessellation Language, which is what goes into the software that prepares the model for 3D printing. That's a mesh, basically, so you need something. FreeCAD will edit it, Mesh Mixer, you can edit it in there. 123D Design will load it, but it won't actually edit it. But yeah, there is free software, you can modify those files. Similarly, if you can find a SolidWorks file and you get Onshape, which is the web-based CAD I described, you can open that in there, so you can make some modifications, or at least you could maybe copy and paste that barrel and shift it and overlap to make it longer, or something simple like that. You could do that in 123D Design. So yeah, absolutely, you could go and do that, or you could go and CAD your own item up, or your own custom end for it. Of course, this is made in different pieces, so you could print all of the body up to here from the file you downloaded. Then you could make a custom emitter or whatever it's called and stick that on instead. So yeah, you've got no problem doing that.
That's no, because that wasn't covered in the other point. And STL, I believe that's a standard file sort of format, isn't it? Because I believe James was mentioning that, and again, we're going to probably address this just a little bit later. That you can the 3D printing community, they happily distribute some of these designs for free, and people can just take them and they can modify them.
Yeah, there's certainly like a community that does that. I mean, RPF, and then there's websites like Thingiverse and Umagine, where you can go and download files for free and then you can play around with them. It is probably worth bearing in mind, though, that once something becomes an STL, you can't really edit it. I mean, you can, but you're not editing it in a very clean way. But there are people who distribute files, freely for everyone. It's not something that we personally do, but that's partly to do with kind of our ownership of the work. And then we don't really feel like it's also for us as protection of quality. So we don't want a file that we produce to go out and be printed in a quality that we're not happy with, and for people to think that that's our work. But that's us. Like, we think it's amazing that, like, there are things that we do share. There's a lot of files that we have made which are around actually improving 3D printing rather than actual, like, files. So things to make your machine a little bit better. But usually we tend to keep stuff to ourselves. But, that's us.
No, fair enough, because as we were illustrating earlier, it's, you spent the time, and you want to be rewarded for it, even though... I don't know, there's this thing about the internet now, because it's online, everything is free, movies, even though that's pirated and stuff like that. But, even like comics are now online, because, once upon a time you have to go into a comic book shop. But no, you can get that for free. But again, it's like, well, no, some poor sod, because I used to be a comic artist, spent a bloody long time drawing that stuff, and he should be rewarded for his work, not just, this comic is so rubbish and I didn't even pay for it. And yeah, that gets on my nerves a lot.
Yeah, absolutely. It's the same thing. It's really, you kind of hit the nail on the head there. It's to do with intellectual property and property ownership, and to say that, you know, I made this thing and it is mine. If I want to share that, that's my business. But if I don't, then you're kind of stealing it from me.
Indeed, and again, this just sounds too good to be true. But I guess, of course, it also depends if people are gonna spend that extra money to get their own 3D printer. But as you say, there are services, but obviously it would cost. Yeah, I've been looking around at some of the costs, and it was like 20 pence per square centimeter. Would that be reasonable or something like that?
Yeah, it's not too bad. It's probably a cubic centimetre, but that's actually pretty reasonable. There's probably a setup cost, so they've got a minimum cost on each part. But, you know, work out was, I don't know, this is hollow, so obviously it's cubic, you know, it's only the cubic value of the hollow plastic. So, yeah, I don't know what that would cost to print on Shapeways or 3D Hubs, but probably less than, you know, £30-40 maybe. So, you know, for a prop like that that's custom, yeah, that's pretty good value, I guess. If you customed your own parts for it as well. So, incredible. Yeah, I think it's quite good value.
Incredible.
If you do it right.
Again, this is incredible. And again, finally, the other point I guess would be, yeah, you don't necessarily need a 3D printer. Like we talked about it before. You can just have your stuff sent off, and it would be sent back to you.
Yeah, absolutely. I'd say for sure, like the if you want to start with 3D printing, the thing you should really be starting with is getting familiar with content creation. And then the actual production, like, you know, there's websites like 3D Hubs, which connect you with companies like my own, or I'm sure James may be on there himself. And that basically, people send us their STLs and say, can you give us a quote? And you 3D print it and you ship it off to them. And then, of course, you've got Shapeways and iMaterialize and other companies like that who've got more professional grade machines, and you can just send it. You can send your files to get printed somewhere else and brought back to you. And I'd say that's definitely a great way to get started, because really the value is your ability to create. You know, I guess the same thing would be like saying, oh, how do I become an artist? You know, step one, learn how to draw, right?
Oh yes, very important. Yes. Okay. And finally, to wrap it up, well, like I said, we're good. We're good. We're running just a little bit over, but finally, the most important thing is, now, how can people get into 3D printing? Now, again, James has already addressed this. I believe there's a lot of free software, and there's a lot of not so free software that people can just pick up. But starting from the beginning, do you need a reasonable size rig? Could I, in theory, do it with I don't know, a store-bought laptop with integrated graphics card, or do I really need a decent enough PC?
I think when you're starting out, you can really use a relatively basic computer, and there are free software out there. I would always recommend modeling software versus visualization software. So there is something out there which is called Fusion 360, which is what 2052 now uses for everything, and that's free to startups, students, and the people who just want to mess around. So I would start with that, because that as a bit of software it's really easy to get into, and it also uses real world dimensions, which is absolutely critical when you want to make something that's 3D printed. So there's things like SketchUp, and then there's also like Blender, which are the two main free ones. Yes. But Blender is a visualization software. It's not designed for anything that's going to be in the real world. So to me, it doesn't have value in 3D printing. And then SketchUp is, well, I just don't like SketchUp. Like, I just think it's a bit rubbish.
Explain yourself, because I like to know. Because again, we had a similar argument with people that said, I'm not going to get Photoshop. I'm just going to use PaintShop Pro. It does the same stuff.
Well, SketchUp is extremely basic, and SketchUp is really good at straight lines. But really, how often, if you're doing a prop, are you going to be using only straight lines?
Yes.
Like, unless you're doing like a pixel version of something, it's not any good to you. Whereas, like, I would actually say, like, Blender sits above Blender sits above SketchUp, because Blender is a lot. Excuse me. Blender is a much kind of more developed tool. You can do a lot more with it. But again, it's not designed for the real world. It's designed to sit in your screen and only sit in your screen. Whereas something like Fusion is designed so that you're building real stuff, and you can do assemblies with it, and you can even prep direct to 3D printing for it, which is one of the biggest appeals for us at 2052, was to say, oh, amazing, we can produce our STLs straight out of the software, and it does really, really good STLs. And then if someone like, when you start to get into it and you can start playing around with other stuff, like there's a sculpting environment. Anyway, I'm going to end up advocating a bit of software.
No. And back onto how we can get started then. And so, okay, so it's that's straightforward. Again, that was illustrated before. It was, yes, there are 3D programs that you can freely pick up, and they're good, right? They are definitely good. I mean, I heard that there were some really awfully expensive ones which were like £6,000 for just software, which kind of makes my eyes watered, because I even thought £1,000 for Photoshop was like more than enough.
Yeah, CAD software can be incredibly expensive, but the market's kind of changing, and I think that the one that I mentioned before, Fusion's really leading the way. So that's free, and it is it's professional grade software. There are people who use this for, they're producing stuff for Coca-Cola and Philips and other companies like that, and even when you do pay for it, it's pretty damn cheap. It's like I think it's like $40-50 a month.
Oh, there's a cloud-based service, because that was one of the recent new great things about Adobe. They started, because they kind of realized people were just pirating their software, because obviously no one was going to pay £800-1,000, but they started to offer a cloud service, like a phone subscription, and that was a bit more reasonable. Although I still think it's a bit steep. So how much would that be then? Per month, or is it per year?
With Fusion, I mean, Fusion for cosplayers and Fusion for kind of anyone listening, it's going to be free for them.
Oh, okay.
So unless you're using it professionally, and even if you are using it professionally, there is a threshold. So it's like, I think it's if your company is making more than $50,000 a year,
I see,
then you pay for it. But if you aren't hitting that threshold, then it's free for you anyway, and like you get access to everything in the software for free.
Oh.
There's no limitation. It's not like there's a free version and there's a full version. They're both the same thing. Which I find really interesting and exciting, because they're basically saying, like, look, guys, like, be cool. If you're earning enough to actually pay for the software, please pay for it. But otherwise, just use it and have fun.
That's pretty excellent, because again, there was always you had silliness like Photoshop Elements, although I think that was okay, because a lot of people were using Photoshop for, well, not its intended purpose, which was to actually edit photos, but for like drawing stuff and all that. Interesting. So it's the same software. Okay, that's incredible. Damn. And it wasn't a point written down, and again, because I had a hard time trying to put this question there. But I guess it would be ownership, because I believe before in an example that you freely distributed some files, but a lot of people just simply didn't credit you. And how did that work out? Because I'm wondering, it must be kind of like PC modding, where you come up with, let's say, this great gun, but then some guy said modified it a bit, and then a third guy modified it a bit, and before you know it, it's a completely different gun, but the third guy says, no, that's my gun, and then the second guy says, no, that's my gun, and then you're thinking, actually, guys, it's all my gun. So how does this work out then?
I think in the end, we just accepted that if we're sharing things online, then we have to take it part and parcel with that, to say that, all right, if we're distributing things online, for us, we're saying we're only going to start distributing things open source. So if we're distributing them open source, we're also accepting that people out there are going to make modifications, and they're going to take ownership of that. And that's kind of okay. I mean, open source is a really great and interesting way of sharing stuff. Before, we were doing it as Creative Commons, and so Creative Commons was saying, like, yeah, you can have it and you can play around with it, but you have to credit us and you can't change it. And the reality is that we're not there yet. Our attitudes aren't there really to say, like, oh, okay, someone else made that, I'm going to respect that. There are people who certainly do that, and they do respect that, but there's not enough in this particular community right now. So we've just kind of accepted that we're not there, and like, if we want to do it, open source is the way to do it. And in a way, open source is kind of better, because you're really just saying, like, here's something I made, and I would really love to see what you guys are going to do with it next.
Okay. Oh, actually, since we were mentioning the chess piece, you were using this rather unusual technology where it just looked like you were using the webcam on your laptop and you were scanning us, and then from there you were able to create a 3D image. Now, I surely thought that, for scanning, for scanning body parts, you would involve much more elaborate technology, like, putting little white balls on, using a green screen and all that. So how is that possible?
So that scanner that we were using that day, that uses for all intents and purposes, it's essentially an Xbox Kinect. It's
Whoa.
it's like a 3D camera and an infrared sensor combined together. And then it just basically it's constantly firing a point onto that surface, and the 3D camera picks that up relative to that space, and that's how it builds a 3D model. There are actually, like, the more advanced 3D scanners still use that method of you having to draw white crosses onto your object to use as reference points to get a much higher fidelity model. But 3D scanning, I would say with 3D scanning, don't think that you can 3D scan an object and then 3D print it out and you've got a prop. Like, it won't work like that.
Oh,
like,
I
3D
see.
scanning is not there yet. Like, 3D scanning is great for referencing, or like the way that we were using it on that day, which was to take real people and turn them into scale models and shrink them down. But beyond that, I don't really rate it. Like, I've had the opportunity to use props and then to scan those props and then to model on them, and it doesn't work. Like, in the end, we did it and we thought, doesn't work. We'll just model it from scratch. It's actually faster and better.
I see. It's the equivalent of rotoscoping in animation, because again, a lot of people in the early days of animation, they just literally videoed people and they would trace over their lines, but as they later on discovered, it looks like people are like, they have no weight to them. It's like they're in 0G, and what people ended up having to do is they had to like compensate for the lack of weight. And then somebody said, well, why did we just do it all by hand in the first place?
Yeah, it's essentially the same thing. Absolutely.
Okay, incredible. So we're not quite at the standard yet where you could just use that same technology, let's say scan in my Mr. Amrad's hidden blade and essentially copy it.
No, not at all. Actually, if I were to replicate that, I would measure it with a pair of calipers and rulers and then just model it by hand.
Okay, that's fascinating. And edit off. And but anyway, thank you very much, Mr. Paul Sohi, for your time. And the one last thing I asked is, where can we find you? What's your social reach then?
You can reach us on Twitter, which is at 2052SN. We have a Facebook page, which is facebook.com/2052props. And then we have a Tumblr as well, which is Studio 2052. And that's us.
Excellent. Okay, thank you very much for your time, mate.
Yeah, no problem. Thank you. Thanks. All right.
Well, anyway, that nicely takes us to the end of this session, and what I've left to say is thank you very much, Mr. James Bruton, for your time. This has been incredibly informative, and I had no idea it was that easy. Again, I surely thought there was a lot more to it.
Well, no problem. There we go.
Okay, thank you very much, and adios.
Okay, thanks.